Okay, corn children, we are going to be using a tangent line to approximate a value. Here's the idea. We have a function. The function itself might be difficult to work with if we want to fill in the value of 2.1. Think about what I'd have to do by hand if I needed to do that. I'd need to do 2.1 to the fourth power, get an answer, multiply by 1/4, add 2. Not really looking forward to doing that. So what we're going to be doing is not finding the actual value, but approximating the value by the use of a tangent line. So I went ahead and I graphed this on the graphing calculator, and at the value of 2, if you fill 2 into this, you get a height of 6. So here's the idea. I'm just going to approximate these. 2, 6 is a point on this curve, and the curve does about like so, and that's the F curve. Now, our job is to approximate the height of the function at 2.1. So 2.1 is just a little bit over from that. So somewhere here, we have the actual height of f of 2.1. But again, filling 2.1 into this function by hand is going to be a freaking nightmare. So we don't want to do that. We're going to approximate it instead. Approximate it with what? Well, we're going to find the equation of the tangent line. And take a look at this. The tangent line at 2.1 is almost the same height as the actual function. If we're near the point of 2, 6, and 2.1 is pretty close, the tangent line height and the function height are pretty close. That will be the tangent approximation at 2.1. All right, so how do we go about doing this? Well, we need to come up with the equation of a tangent line at a value of 2. Well, what do you need? You need a point and you need a slope. So let's start with the point. In order to find, we need a point and we need a slope. We've been given the x-coordinate of 2. The tangent line is at 2, not the approximate value 2.1. The tangent line is touching at 2. So it says right here, at 2. I'm going to go ahead and fill 2 into this function. I'm kind of assuming we don't have a calculator, so filling 2 into the function. Don't worry, it's not that bad. 2 to the 4th is 16. Oh, look, we can do that without a calculator. And we get 4 plus 2 is 6. So my y-coordinate is 6. The point is 2, 6. Now what about the slope? Well, we have to remember something. The slope of a tangent line is found using the derivative. Oh, we should probably take the derivative then. F of x, 1/4 x to the 4th plus 2, f prime of x, scalar of 1/4, power rule, the 4 comes down, x cubed, the derivative of a constant is 0. Oh, look how nice that is. So this will give us the slope of the tangent lines anywhere along the curve. Well, we don't want it anywhere. We want the slope specifically when x is 2. So we fill 2 in. And this is the slope of our tangent line. All right, we have here a point. We have a slope. Perhaps we should use point-slope form of a line. Point-slope form. All I'm going to do, fill in my x and my y, fill in my m. So y minus the y-coordinate of the point, slope, x minus the x-coordinate of the point. I'm going to go ahead, I'm not even going to distribute. I'm going to move the 6 to the other side though. So here's what we have. This is the equation of the tangent line. I can use the y-coordinates of the tangent line to approximate y-coordinates of the function. So I'm going to take this equation, and I'm going to bring it back up to my picture so you can look at it. And the equation of this tangent line is y equals 8 times x minus 2 plus 6. We want to approximate the height of the function by using the height of the tangent line. In other words, f of 2.1, the actual height on the function, can be approximated by putting 2.1 not into the function itself, that'd be exact, not approximate, but putting 2.1 into the equation of the tangent line. Oh, do you see why I didn't distribute? This is easy to subtract when I don't distribute. Even without a calculator, we can do this math. And I get 6.8. This is not the height of the function. It is approximately the height of the function. We have just calculated the height on the tangent line, not the height of the function, but they're really close together. So this is our tangent line approximation to the curve at the value of 2.1. It's not too bad.